Project Management Professional Training Session 8 Part 2. Planning Quality and Risk Management. Tools and Techniques for Quantitative Analysis. Quantitative risk analysis can be looked upon as a two-step process: gathering and representing the data, and analyzing and modeling the data. Accordingly, all the techniques fall into two categories: data gathering and representation techniques, such as interviewing, probability distributions, and expert judgment, and analysis and modeling techniques, such as sensitivity analysis, EMV analysis, decision tree analysis, and modeling and simulation. Interviewing: this technique is used to collect data for assessing the probability of achieving specific project objectives. You are looking for results such as, we have a 70% probability of finishing the project within the schedule desired by the customer. Or perhaps, we have a 60% probability of finishing the project within the budget of $100,000. The goal is to determine the scale of probabilities for a given objective. For example, there is a 20% probability that the project will cost $50,000, a 60% probability that it will cost $100,000, and a 20% probability that it will cost $150,000. The data is collected by interviewing relevant stakeholders and subject matter experts. Most commonly, you will be exploring the optimistic, best case, pessimistic, worst case, and most likely scenarios for a given objective. For example, for the project cost, the optimistic estimate might be $10 million, the pessimistic estimate might be $50 million, and the most likely estimate might be $25 million. Representation of uncertainty, probability distributions. The risks and uncertainty found in the input into the quantitative risk analysis, discussed in the previous section, need to be modeled. In Step 5 of the previous section, we discussed that uncertainty can be modeled as probability distributions, and the effects of individual project risks can be included in these distributions or be modeled separately as probability branches. The data on meeting the project objectives can be presented in a probability distribution for each objective under study. Note that, by definition, a distribution represents uncertainty, and a risk also represents uncertainty. For example, if you know for sure the project will cost $25 million, there will be no distribution because it is only one data point. Probability distribution comes into the picture when you have several possible values, with a probability assigned to each value. There are distributions of different shapes in which the data can be presented. The commonly used distributions, according to PMP 6th edition, are uniform, beta, triangular, normal, log normal, and discrete distributions. The uniform distribution is used when all the values of an objective have the same chance of being true. Figure 7.4 shows some of them for the cost objective. The x-axis represents the cost, and the y-axis represents the corresponding probability that the project will be completed within that cost. We do all this modeling for analysis. Sensitivity analysis. This is a technique used to determine which individual risk or other source of uncertainty has the greatest impact on the project outcome. Just for the sake of understating, imagine you study the impact of one risk or uncertain element on a project objective by keeping all other uncertain elements fixed at their baseline values. You can repeat this analysis for several objectives, one at a time. You can also repeat this study for several uncertain elements, creating risks, one element at a time. This way, you can see the impact of each element, or risk, on the overall project separate from other elements, or risks. Practically, you will be using a software package to run this analysis. The strength of impact is measured by investigating the correlation of the variation in project outcome with the variations in different elements of the analysis model, example, various risks and other uncertainty sources. A higher value for the correlation coefficient of an element indicates a higher impact of that element in the project outcome. The analysis may generate plots of correlation coefficients of elements, example, a tornado diagram, which has one bar for each element with a non-zero impact on the project outcome along the x-axis, with the height of the bar along the y-axis representing the value of the correlation coefficient for that element. Modeling and simulation. A model is a set of rules to describe how something works. It takes input and makes predictions as output. The rules might include formulas and functions based on facts, assumptions, or both. A simulation is any analytical method used to imitate a real-life system. Simulations in risk analysis are created using the Monte Carlo technique, which is named after Monte Carlo, France, known for its casinos, which present games of chance based on random behavior. Monte Carlo simulation models take random input iteratively to generate output for certain quantities as predictions. This technique is used in several disciplines, such as physics and biology, in addition to project management. In risk analysis, Monte Carlo is used to simulate the combined effect of identified individual project risks and other uncertainty sources on project outcomes, leading to their impact on meeting the various project objectives. The input is taken randomly from a probability distribution, example about cost and duration estimates, and the output for impact on the project objectives is predicted. The name Monte Carlo refers to the random behavior of the input, i.e., input can be selected randomly. In that spirit, it could easily be called Las Vegas. Tip S-curve, simulation analysis can generate cumulative probability diagrams, called S-curves, in which the x-axis represents the predicted value of a project variable such as cost, while the y-axis represents the cumulative probability for the predicted values. As already mentioned, the effects of individual project risks may be included in these distributions or can be modeled separately as probability branches. We now will discuss the probability branches, for which you need to understand the concept of expected monetary value. Expected monetary value analysis, expected monetary value, EMV, analysis is used to calculate the expected value of an outcome when different possible scenarios exist for different values of the outcome with some probabilities assigned to them. The goal here is to calculate the expected final result of a probabilistic situation. EMV is calculated by multiplying the value of each possible outcome by the probability of its occurrence and adding the results. For example, if there is 60% probability that an opportunity will earn you $1,000 and a 40% probability that it will only earn you $500, the EMV is calculated as follows. EMV is equal to 0.60 times 1000 plus 0.40 times 500 is equal to 600 plus 200 is equal to 800. So, the EMV in this case is $800. When you are using opportunities and threats in the same calculation, you should express EMV for an opportunity as a positive value and that for a threat as a negative value. For example, if there is a 60% chance that you will benefit from a risk by $1,000 and a 40% probability that you will lose $400 as a result of this risk, the EMV is calculated as follows. EMV is equal to 0.60 times 1000, 0.40 times 500 is equal to 600, 200 is equal to 400. Therefore, the EMV in this case is $400. The concept of EMV can be presented in a decision-making technique, such as a decision tree analysis. Decision tree analysis. This technique uses the decision tree diagram to choose from different available options. Each option is represented by a branch of the tree. This technique is used when there are multiple possible outcomes with different threats or opportunities with certain probabilities assigned to them. EMV analysis is done along each branch, which helps you to make a decision about which option to choose. Figure 7.5 presents a very simple decision tree diagram that depicts two options: updating an existing product or building a new product from scratch. The initial cost for the update option is $50,000, whereas the initial cost for the build from scratch option is $70,000. However, the probability for failure is 40% for the update option, compared to 10% for the build from scratch option, and the impact from failure in both cases is a loss of $200,000. As study checkpoint 7.4 shows, even though the initial cost for the update option is less than the initial cost for the build from scratch option, the decision will be made in favor of the build from scratch option because when you combine the initial cost with the EMV resulting from the probability of failure, the build from scratch option turns out to be a better deal. Study checkpoint 7.4. Perform the EMV analysis of the decision tree presented in Figure 7.5 to make a decision on which option to take. Influence diagram. An influence diagram is a graphical representation of uncertain situations that shows relationships among various variables and outcomes, such as causal influences and time ordering of events. By examining these diagrams, the risk management team can recognize the potential problem areas and thereby identify risks in various options and make the right decisions under uncertainty. Interviews and expert judgment. In quantitative risk analysis, interviews can be used as a data gathering tool, such as to get information from experts, and expert judgment can be used to, for example, select appropriate risk modeling techniques, validate the collected risk data and the analysis used for the project at hand, and so forth. The risk register is updated with the results of the quantitative risk analysis. Output of the quantitative risk analysis, updated risk report. The risk report that is used as an input item to the quantitative risk analysis is updated with the results of this analysis. The updates include the following: project success, probability of achieving the project objectives. Chances of project success are reported and evaluated by factoring in the project risks and estimating the probability of meeting project objectives, such as cost and schedule, set forth by the current project plan. For example, the likelihood of completing the project within the current budget plan of $2 million is 70%. Overall project risk effect, probabilistic analysis of the project. This includes the key outputs from quantitative risk analysis with some details, example, estimates of the project schedule and cost with a confidence level attached to each estimate. Confidence level can be expressed in percentage form, such as 95%, and it represents how certain you are about the estimate. You can compare these estimates to the stakeholders' risk tolerances to see whether the project is within the acceptable limits. The detail can also include S-curve, tornado diagrams, etc. Prioritized list of risks. The risks are prioritized according to the threats they pose or the opportunities they offer. The risks with greater threats, or opportunities, are higher on the list. The priorities are determined based on the total effect of each risk on the overall project objectives. The purpose of prioritizing risks is to help with planning the response efforts to eliminate, or minimize, the impact of the threats and capitalize on the opportunities. Trends in the results. By repeating the analysis several times and by examining the results, you might recognize a trend for specific risks. That trend might suggest further analysis or a specific risk response. Risk response recommendations. The risk report can recommend specific responses to key risks based on their overall effect on the project. The emphasis in quantitative analysis is on two tasks: assess the probability of meeting each project objective and prioritize the risks based on their total effect on the overall project objectives. Subsequently, the resultant prioritized list of risks can be used to prepare the risk response plan. Planning the risk response. The plan risk response process develops the risk response plan, which includes options, actions, and strategies for responding to risks at both levels, individual project risks and overall project risks. Accordingly, the central task in risk response planning is to develop actions and options to meet the following goals: minimize threats to meeting project objectives, maximize opportunities, reduce the overall project risk effect. Tip: remember the 5-prong golden rule for risk response planning, AARCO. A risk response must be appropriate in matching to the significance of the risk, agreed upon, realistic within the context of the project, cost-effective, and owned by the appropriate stakeholder. Table 710 presents the plan risk response process in terms of input, tools and techniques, and output. Table 710. The plan risk response process: input, tools and techniques, and output. Input, tools and techniques. Output. 1. Project management plan. Risk management plan. Resource management plan. Cost baseline. 2. Project documents. Risk register. Risk report. Resource calendars. Project schedule. Project team assignments. Stakeholder register. Lessons learned register. 5. Enterprise environmental factors. 6. Organizational project assets. 1. Data gathering. Interviews. 2. Data analysis. Cost-benefit analysis. Alternatives analysis. 3. Multi-criteria decision-making analysis. 4. Strategies for negative risks, threats. 6. Strategies for positive risks, opportunities. 7. Strategies for overall project risk. 8. Strategies for contingent response. 9. Interpersonal and team skills, facilitation. 10. Expert judgment. 1. Change requests. 2. Management plan updates. Schedule management plan. Cost management plan. Quality management plan. Resource management plan. Procurement management plan. Scope baseline. Schedule baseline. Cost baseline. 3. Project document updates. Risk register. Risk report. Cost forecasts. Project schedule. Project team assignments. Assumptions log. Lessons learned register. Core of risk response planning. Performing the planned risk response process includes the following steps. 1. Determine the responses to individual project risks and overall project risk. 2. Determine the strategy to implement the responses. 3. Determine the response implementation, related activities and manage inserting them in appropriate project and plan documents. In light of this, performing the planned risk response process may be explained in the following steps in terms of the items from Table 710. 1. Get information about risks and response strategy. From the risk report, you can obtain a prioritized list of individual project risks, overall project risk, the specific response recommendations for key risks, as well as the overall response strategy. More detailed information about any identified risks can be obtained from the risk register, such as priority, owner, cause, and other data that may help to determine a response. 2. Get information about risk owners and roles. The owner of each is assigned in the risk register. The risk management plan contains the information on risk management roles and the responsibilities assigned to each role, as well as the risk threshold. The owner and persons assigned to roles will play an important role in finding and allocating resources for implementing the risk responses. 3. Use information about risks to determine risk response strategies. Use these strategies to develop risk response activities. 4. Get information about resources to implement risk responses. From the project team assignments and resource calendars, you can get information on resources responses and their availability. Information on the contingency funds allocated to risk responses can be found in the cost baseline. 5. Integrate the risk response activities with project. From the resource management plan, get information on how the resources allocated to risk response activities will be coordinated with other project resources. You will need the project schedule to schedule risk response activities with other scheduled project activities. For Step 3, considering different risk response strategies and selecting appropriate ones for the project, we will need to use some tools and techniques. Tools and techniques for risk response planning. The main goal of this process is to determine the appropriate risk response strategies and schedule the related activities. When developing risk responses, you can interview the appropriate stakeholders to collect needed information or data and use interpersonal and team skills like facilitation to help risk owners understand the risk and appropriate response strategy, and you can also use exert judgment on topics of different risk strategies. To understand the risk strategies, let's start from risk, which, as you have already learned, can come in two categories: negative risks, which pose threats to meeting the project objectives, and positive risks, which offer opportunities. The goal here is to minimize the threats and maximize the opportunities. In project management, there are three kinds of possible responses to risks: take an action, take no action, or take a conditional action. When you want to take an action, different response strategies for negative and positive risks need to be planned. Also, we want to strategize the responses to overall project risk. Accordingly, there are three kinds of strategies available to handle three kinds of scenarios. Strategies to respond to negative risks, threats, when action is required. Strategies to respond to positive risks, opportunities, when action is required. Strategies that can be used to respond to overall project risks. Response strategies for threats. There are two strategies in which no proactive action is taken. Escalate. The risks that are out of the scope of project or project team authority are escalated to a higher level, example, program, portfolio, or some other part of the organization. It is done with the consent of the project sponsor or another authorized person. Except, this strategy is usually applied to low-priority risks or risks for which there is no viable response. Here, the risk is accepted without taking any proactive action. In passive mode, nothing except periodic review is done until the risk priority gets higher. In active mode, some contingency resources are reserved to handle the situation if the risk occurs, called a contingent response. For risks that need action by the project team, there are only three common-sense ways to take action against a potential problem: get out of harm's way, pass it to someone else, or confront it to minimize the damage. In project management, these three strategies are called avoid, transfer, and mitigate, the ATM approach. Avoid. This is used for high-priority threats with high impact and a high probability of occurring. The goal is to eliminate the risk or impact on the project. Example, you avoid the risk by changing your project management plan in such a way that the risk is eliminated. Depending upon the situation, this can be accomplished in various ways, including the following. Obtaining information and clarifying requirements for risks based on misunderstanding or miscommunication. This answers two questions: do we really have this risk, and, if yes, how can we avoid it? Removing the cause of the risk. Acquiring expertise for risks that exist due to a lack of expertise. Isolating the project objectives from the risk whenever possible. Relaxing the objective that is under threat, such as extending the project schedule or adding resources. Transfer. Risk transfer means you shift the responsibility for responding to the risk, the ownership of the risk, and the negative impact of the risk to another party. Note that transferring the risk transfers the responsibility for risk management and does not necessarily eliminate the risk. Risk transfer almost always involves making payment of a risk premium to the party to which the risk has been transferred. Some examples include buying an insurance policy, contracting out the tasks involving risk, and include risk owner transfer. Mitigate. Mitigation in general means taking action to reduce or prevent the impact of a disaster that is expected to occur. Risk mitigation means reducing the probability of risk occurrence, reducing the impact of the risk if it does occur, or both. A good mitigation strategy is to take action early on to first reduce the probability of the risk happening, and then to plan for reducing its impact if it does occur, rather than letting it occur and then trying to reduce the impact or repair the damage. The following are some examples of mitigation. Adopting less complex processes. Conducting more tests on the product or service of the project. Choosing a more stable supplier for the project supplies. Designing redundancy into a system so that if one part fails, the redundant part takes over, and the system keeps working. Each of these strategies has a counter strategy to deal with the opportunities. Response strategies for opportunities. There are two strategies, escalate and accept, in which no proactive action is taken, and they are applied the same as in the case of threats. For risks that need action by the project team, just like in the case of threats, you have three strategies to deal with opportunities. Not surprisingly, each response strategy to deal with an opportunity is a counterpart of a response strategy to deal with a threat. A one-to-one correspondence. Share corresponds to transfer. Exploit corresponds to avoid. Enhance corresponds to mitigate. You use the SEE, share, exploit, enhance, approach to deal with the opportunities presented by the positive risks. Sharing a positive risk that presents an opportunity means transferring the ownership of the risk to another party that is better equipped to capitalize on the opportunity. Some examples of sharing are: forming risk-sharing partnerships, starting a joint venture with the purpose of capitalizing on an opportunity, forming teams or special-purpose companies to exploit opportunities presented by positive risks. Exploit. This is used for high-priority opportunities with high impact and a high probability of occurring. Exploiting an opportunity means ensuring that the opportunity is realized, that is, that the positive risk that presents the opportunity does occur. This is accomplished by eliminating or minimizing the uncertainty associated with the risk occurrence. An example of exploiting is assigning more talented resources to the project to reduce the completion time and therefore to be the first to market. Another example could be to provide better quality than planned to beat a competitor, and doing so by using a new technology. Whereas exploiting refers to ensuring that the positive risk occurs, enhancing refers to increasing the impact of the risk once it occurs. Enhance. This strategy means increasing the size of the opportunity by increasing the probability, impact, or both. You can increase the probability by maximizing the key drivers of the positive risks or by strengthening the causes of the risks. Similarly, you can increase the impact by focusing on the factors that drive the risk impact. You have just learned the different strategies that you need in order to plan for negative and positive risks if you intend to take action. If, on the other hand, you intend to take no action or a conditional action, then the response planning strategies for both negative and positive risks are the same. Response strategies for overall project risk. An overall project risk, like an individual risk, can be a threat or an opportunity. So, the same strategies as in threat and opportunity can be applied to overall project risk. These strategies are share/transfer, exploit/avoid, enhance/mitigate, and accept. Contingency. Generally speaking, contingency means a future event or condition that is possible but cannot be predicted with certainty. So, your action will be contingent upon the condition, that is, it will be executed only if the condition happens. In risk management, a contingent response is a response that is executed only if certain predefined conditions, or events, happen. These events trigger the contingency response. Some examples of such triggers are missing a milestone or a customer's escalating the priority of a feature. The events that can trigger a contingency response must be clearly defined and tracked. Caution: while designing a response to a risk, also design a backup plan in case the response does not work. Also, think through and plan for responding to the risks that the response to the original, primary, risk may cause. These risks are called secondary risks. To select which of the strategies to apply to your project, you use data analysis and decision-making techniques. Data analysis and decision-making. Already discussed in this book more than once, alternatives analysis, cost-benefit analysis, and multi-criteria decision-making analysis can be used to select the appropriate risk response strategy in a given situation. In this process, alternatives analysis is applied by comparing the features and requirements of risk response strategies, and in this way can help you decide which strategy is the best. In cost-benefit analysis, the cost-effectiveness of a response is computed as cost-effectiveness equals change in risk impact level / response implementation cost. The higher the cost-effectiveness value is, the better the risk response strategy is. In multi-criteria decision-making analysis, the response strategies are selected by ranking them on several criteria, example, resource availability, response effectiveness, creation of secondary risks by the response, and time constraints. Study checkpoint 7.5. You are the project manager of a movie shooting project. The first column lists some actions you are taking to deal with risks. Match each item in the first column with one item in the second column of this table. You use these strategies to generate the output of the risk response planning process. Action risk response type. A. One of the scenes is to be shot in a country that has enormous bureaucracy and red tape. They possibly can create roadblocks and make it difficult for you. There is nothing much you can plan about it. 1. Avoid. B. The jungle where you are going to shoot a few scenes is a wetland and very hot and humid, and the probability of damage happening to the equipment is very high. So, you have decided to buy insurance to protect you against this possible damage. 2. Accept. C. You have learned that during a certain time of the year, the locals come to hunt in the jungle in big numbers. So, you have decided not to do the shoot during that part of the year. 3. Exploit. D. Although the movie does not depend on it, it will add a lot of marketing value to the movie if your cameras could capture an endangered species of birds that live in the jungle. You are choosing the time of the year for shooting and taking some other actions to increase the probability that the birds will show up. 4. Share. E. The movie has something to do with Thanksgiving Day. You have put in some extra resources to ensure that the movie is completed in a timely manner for a release on Thanksgiving Day. 5. Mitigate. F. You have learned that there could be mosquitoes in the area in which you are going to shoot. So, you have planned to take plenty of mosquito repellent and other products to prevent mosquito bites. 6. Enhance. G. You know another movie team that's going to shoot some scenes in the same jungle during a different time of the year. You have signed a contract with them to share or trade the shots of the endangered bird species. 7. Transfer. Output of risk response planning. The main output of this process is appropriate risk response and strategies, and the related schedule activities with assigned resources. The plan risk responses process does not create any document such as a risk response management plan. Instead, its output is inserted into already existing project plans and project documents as discussed in the following paragraphs. Risk register and risk report updates. The appropriate risk responses and strategies planned and agreed upon by the risk management team are included in the risk register. The responses to high priority and moderate priority risks are entered in detail, while the low priority risks can be put on a watch list for monitoring. Other items added to the risk register as a result of this process may include the following: planned and agreed upon risk response strategies and specific actions to implement each strategy. Symptoms and warning signs of risk occurrences, contingency plans and triggers for contingency risks. Budget and schedule activities to implement the planned responses, including the contingency reserve, which is the amount of funds, time, or both needed. Fallback plans in case the planned responses prove to be inadequate. A list of risks to remain, which include the following: passive, accepted risks. Residual risks that will remain after planned responses have been performed. A list of secondary risks that will arise as a result of implementing the responses. You must plan for these risks like any other risk. Similarly, the risk report can be updated with planned responses to the overall project risk and the resulting impact changes that are expected from the implementation of these responses. Other document updates. The documents that may change as a result of this process are listed in the output column of Table 710. The change or update is triggered by the action of inserting the output of this process into project plans and project documents. For example, scheduling the risk response related activities updates the project schedule and project team assignments. These changes may require or lead to changes in or updates to the scope baseline, schedule baseline, cost baseline, and other items listed in the output column of Table 710. Change requests for proposed changes to any component of the project plan, such as scope baseline, schedule baseline, and schedule management plan. Change requests must be generated and processed through the Perform Integrated Change Control process. Note: a residual risk is the remains of a risk on which a response has been performed, whereas a secondary risk is a risk that is expected to arise as a result of implementing a risk response. Therefore, a response for a secondary risk must also be planned. In a nutshell, risk response planning examines and selects the risk response strategies, uses these strategies to plan responses to individual project risks and overall project risk, assigns resources to these response activities, and schedules them. Once risk responses have been planned, you need to implement them and control this implementation, which will be discussed in the execution and monitoring and controlling parts of the book. The three most important takeaways from this chapter are as follows. 1. The goal for quality planning is twofold: identify quality requirements and standards for your project, and specify how to determine whether the project and its product satisfy these requirements and standards. 2. Planning risk involves developing the risk management plan, identifying risks, prioritizing risks, and preparing risk responses. 3. The in-sync development and implementation of the quality management plan and risk management plan is crucial for project success as it delivers the right and complete product. Summary. Quality management includes planning quality, managing quality, and controlling quality. The quality management plan and quality metrics are the major output items of the quality planning process called plan quality. Quality and risk are two interrelated aspects of any project and need to be managed. Risk refers to an uncertain event or condition that, if it occurs, has a positive or negative effect on meeting the project objectives, hence posing threats or offering opportunities, respectively. Risk management includes planning risk management, identifying and analyzing the risks, planning and preparing the risk responses, implementing the risk response if the risk occurs, and monitoring the risks. The only output of risk management planning is the risk management plan, which includes elements such as a list of tools and approaches to be used for risk management, identification and assignment of resources for risk management, defining risk categories, risk probabilities and impacts, and the format of risk reporting and tracking. This information is used in the remaining processes of risk management: identify risks, perform qualitative risk analysis, perform quantitative risk analysis, plan risk responses, implement risk responses, and monitor risks. The risk identification process initiates two documents as output: the risk register, which contains information about identified individual project risks, and the risk report, which contains information about overall project risk. Both of these items are added to or modified by other risk management processes. The main output of qualitative risk analysis is the prioritization of risks based on a probability and impact matrix for each objective. Each objective might have its own prioritized list of risks. However, the emphasis in quantitative analysis is on two things: assessing the probability of meeting each project objective and prioritizing the risks based on the total impact of each risk on the overall project objectives. Subsequently, the resultant prioritized list of risks can be used to prepare the risk response plan. Risk response planning examines and selects the risk response strategies, uses these strategies to plan responses to individual project risks and overall project risk, assigns resources to these response activities, and schedules them. This risk response plan is executed to minimize the impact of threats and maximize the impact of opportunities on the project, which is discussed in the execution part of the book. Road ahead. In Chapter 2, we talked about project stakeholders in some detail, and all through the book we have been making references to them. As you know, starting from the project sponsor to you, to your team, to the customer, and so forth, everybody is a stakeholder. Without stakeholders, there would be no project. This underlines the importance of stakeholder management. You need to communicate with stakeholders, and communication needs to be managed. In the next chapter, we will discuss the planning of these two closely tied aspects of project management, stakeholder management and communication management. Exams I view. Comprehend. Quality management has two quality components to manage, project quality and project product quality, which is linked to project deliverables. Planning quality is all about identifying quality requirements and standards for the project and its deliverables, and then determining how to test and verify that they have been implemented. Risk categorization is a part of the risk management plan and it helps in the risk identification process, which can modify the categories. Defining the risk probability and risk impact are parts of the risk management plan. They are assessed in the qualitative risk analysis to prioritize risk. Risk identification is performed before any risk analysis, and the qualitative risk analysis, if performed, is performed before quantitative risk analysis because it takes less effort and time and its results can be used for quantitative analysis. The emphasis in quantitative analysis is on two tasks: assess the probability of meeting each project objective and prioritize the risks based on their total effect on overall project objectives. An important update added to the risk register by the qualitative and quantitative risk analyses is the prioritized list of risks. Look out. Quality is not only about defects in the products, it also includes things like process improvement, completing tasks on time, cost, and other aspects of project performance. Risk stems from elements of uncertainty and can have a negative or positive effect on meeting the project objectives. A positive effect is called an opportunity. The risk register and risk report are initially prepared during the risk identification process, and some results from the other risk management processes are added to them. Depending upon the experience of the team and the nature of the risk, a risk can be moved directly after identification to quantitative risk analysis or even to risk response planning. For a simple project, quantitative risk analysis may not be needed. There is no document called the Risk Response Management Plan. The risk response-related activities are inserted into the appropriate project and plan documents. Memorize. The output of the plan quality management process includes quality metrics in addition to the quality management plan. A prompt list is a predetermined list of risk categories that can be used to generate ideas to identify individual project risks. The risk register contains information about individual project risks, and the risk report contains information about the sources of overall project risks and a summary of individual project risks. Review questions. 1. Which of the following is a false statement about project risks? A. A risk arises out of uncertainty. B. A risk can only have a negative effect on a project. C. Identified risks are usually listed in a document called the risk register. D. Risks can be categorized by developing a risk breakdown structure, RBS. 2. The risk register is not an input to which of the following processes? A. Identify risks. B. Perform qualitative risk analysis. C. Perform quantitative risk analysis. D. Implement risk responses. 3. Which of the following is not an information gathering technique listed in PMBOK, 6th edition for use in the risk identification process? A. Brainstorming. B. Delphi technique. C. SWOT analysis. D. Root cause analysis. 4. Which of the following statements about risk analysis is false? A. Quantitative risk analysis can only be performed on risks on which a qualitative risk analysis has already been performed. B. Qualitative risk analysis is usually performed before quantitative risk analysis. C. An updated risk report is the output of both qualitative risk analysis and quantitative risk analysis. D. The risk register is an input to both qualitative risk analysis and quantitative risk analysis. 5. You are managing a project to set up data servers to support a website for an enterprise customer. The location for the servers has been placed close to the customer due to their requirements. However, this location is prone to natural disasters, such as hurricanes and flooding. You have decided to install some extra servers in another city that will act as backup if a disaster happens. This is an example of which of the following? A. Risk avoidance. B. Risk mitigation. C. Risk acceptance. D. Risk transfer. 6. The risk management team of a software project has decided that due to the lack of adequate talent in your company, development of a specific part of the system is under high risk, so they have decided to outsource it. This is an example of which of the following? A. Risk avoidance. B. Risk mitigation. C. Risk acceptance. D. Risk transfer. 7. You are in the process of evaluating the probability and impact of a risk by assigning numbers, such as expected monetary value. This is an example of which of the following? A. The Monte Carlo simulation. B. Qualitative risk analysis. C. Quantitative risk analysis. D. Risk response planning. 8. Consider figure 7.6. Assume that the risk has a 50% probability of occurring. If the risk does occur, it could have a positive or a negative impact equivalent to $200,000 or $50,000, respectively, with the probabilities shown in the figure. What is the EMV for the positive impact? A. $80,000. B. $200,000. C. $50,000. D. $40,000. Nine. Consider figure 7.6. Assume that the risk has a 50% probability of occurring. If the risk does occur, it could have a positive or a negative impact equivalent to $200,000 or $50,000, respectively, with the probabilities shown in the figure. What is the EMV for the risk? A. $25,000. B. $55,000. C. $110,000. D. $50,000. 10. Which of the following is a correct statement about secondary risks? A. These are the residual risks. B. These are the risks that have medium or low priority. C. These are the risks that will be avoided. D. These are the risks that can result from responses to the identified risks. 11. Which of the following is not a valid risk response? A. Risk acceptance. B. Risk sharing. C. Risk mitigation. D. Risk rejection. 12. Which of the following is a valid statement about SWOT? A. It is an analysis technique to identify risks. B. It refers to the analysis of scope, work, options, and timing. C. It is a technique used to plan a risk response. D. It is a technique used to perform quantitative risk analysis. 13. Which of the following is not an output of qualitative risk analysis? A. A prioritized list of risks for a given project objective based on the probability and impact matrix of the objective. B. A watch list of low-priority risks. C. A list of risks prioritized based on the total effect of each risk on the overall project objectives. D. A list of trends in the analysis results. 14. Which of the following is not an output of quantitative risk analysis? A. Probability of meeting the project objectives, such as cost and schedule. B. A list of risks prioritized based on the total combined effect of each risk on the overall project objective. C. A list of trends in the analysis results. D. Decision about a risk-related contractual agreement. 15. What is the name of a quality planning technique that involves comparing the results of similar activities? A. Brainstorming. B. Benchmarking. C. Cost-benefit analysis. D. Quality metrics. 16. What about matrix diagrams is not true? A. It is used in planning quality management. B. It is used in managing quality. C. It is used to explore the effects of defects. D. It helps to find the key quality metrics important for project success. 17. What about quality metrics is not true? A. A metric in quality metrics is a product attribute accompanied by the information on how the quality control process will verify its quality conformance. B. They are an output of planning quality. C. They can be used as a reference or basis for developing the test for quality and for suggesting improvement, example, change request. D. They help to find the key quality metrics important for project success. 18. What about flowcharts is not true? A. They can be used to understand and estimate the cost of quality for a process. B. They can help in improving processes. C. They can be used to identify points where quality defect may occur. D. They help in figuring out the frequency of defects from different attributes of the product during inspection. 19. What about mind mapping is not true? A. This technique is used in the perform quality assurance process. B. This technique may help in figuring out quality requirements. C. It can be used to find constraints. D. It can help to find relationships such as dependencies. 20. The Plan-Do-Check-Act cycle of quality management was A. Defined by Shewhart and modified by Deming. B. Originally defined by Deming and then modified by Shewhart. C. Defined by Crosby and modified by Deming. D. Defined by Crosby and modified by Wan.